All right, hello everyone. Welcome to my channel. This is a channel that is dedicated toward educating the public on various obscure and esoteric topics that could have a revolutionary effect on your life if you knew about them. Things that have been suppressed, people who have been deemed crackpots, who were actually dedicated researchers who spent their whole life working on something and never got paid, never got famous, but continued to work on it anyway, and came up with some fantastic results that nobody knows about. So today is the 348th video that we've done on the reciprocal system of theory. This is a theory that was put forward by Dewey B. Larson back in the 20th century. And this theory is, can be kind of summarized as a universe of motion. We live in a universe made entirely out of motion. And in Larson's world, that is kind of a different kind of motion, what you would call scalar motion. It's a motion that has a magnitude, but it has no direction. It has no units attached to it. You don't say the motion is north or south or anything like that. And this is something that you can model with a clock. The clock is getting later and later and later, but it's not going in any specific direction. You can also use a balloon with spots on it. All of the spots, if you blow up the balloon, all the spots are moving away from each other. And once again, in no particular direction. Each dot is moving away from each other dot. And not only that, but the locations between the dots are moving away from other locations between the dots. All of the locations are moving away from each other, and the farther away they are, the faster they're moving away from each other, like a scale, on a scale, hence scalar motion. And the direction that can be imputed to these motions, and has been imputed to these motions, is the result of a reference system, not as a result of the motion. In order to come up with any type of direction, you have to assign one of these points as being arbitrarily the one that is motionless. You can say, oh, well, we're going to say that this one is motionless. When you do that, then all of a sudden the directions from each one of the other dots becomes more clear. But up until that time, you have a scalar motion with a magnitude but no direction. And this kind of motion has been known by science, but it has not been investigated or understood in its significance. And Larson puts it at the center of his narrative, at the center of his universe of motion. It's a universe of scalar motion. But the legacy scientists have kind of put it over in the closet as kind of a sideshow. Oh, well, we know about this kind of motion, but it's not important. And even though their own Hubble telescope has observed that all of the distant galaxies are moving away from each other, and unless we want to say that our galaxy is at the center of the universe, which we've already, I think we've gotten past that. But unless we want to say that, then our galaxy is also participating in the same motion away from all of the other galaxies. So that is a scalar motion. And also, if you kind of reverse the order and you start sucking in the balloon instead of blowing up the balloon, all of the dots will be moving toward each other. And that is a motion that is analogous to gravitation. And so when you are defining a gravitational field, like this body is moving toward this other body, you are imputing a reference point to that, to one of those bodies. And that is where the field or the direction is coming from. So the gravitational field is not a consequence of the scalar motion. It is a consequence of the reference point that you have assigned arbitrarily. Gravitation is a motion of all locations toward all other locations, analogous to the surface of a contracting balloon. Now, another thing about motion is that motion is the relationship. Other people have had the notion of a universe of motion, but Larson stood out because he defined motion as the relationship between space and time. And I guess I would also say the relationship between time and space. They're both interchangeable. And because space and time are, that creates a reciprocal relationship between space and time, hence the reciprocal system of theory. And space and time are basically not independent entities. They don't exist by themselves. They only exist together in motion. Motion can be thought of as a fraction, with time or space as the numerator and space or time as the denominator. Such as speed. Speed is the car is moving 20 miles per hour. 20 miles of space in 1 hour of time. Space over time. Acceleration. I dropped the rock out of the window and it fell at 32 feet per second. That is acceleration. 32 feet of space in 1 second per second, or 1 second squared. Time over space to the second power is acceleration. So these are relationship fractions of, with time or space as the numerator, space or time as the denominator. Energy. It took me 3 hours to push that thing 1 mile. There's 3 hours of time and 1 mile of space, time over space, energy. And so on and so on and so on. All the scientific quantities that we know of are relationships between space and time. But again, space and time could be in multiple dimensions. That's what Larson calls coordinate space, coordinate time. He's saying that space and time both have 3 dimensions. X, Y, Z coordinates. We're accustomed to that concept in space, 3 dimensions of space. I would say that it could be 4 dimensions as well. But some people might disagree with me about that. I don't know that the dimensions have to be orthogonal, meaning 90-degree angles. I think they need to be independent, but I don't know that that necessarily means orthogonal. Okay, and then also that leaves the concept of coordinate time, 3 dimensions of time, which is a blasphemy for the legacy scientist, but it is an inevitable part of the reciprocal system, because whatever quality adheres to either space or time also adheres to the other space or time. And so you have, so you have coordinate space, coordinate time. And you also have clock space and clock time. The clock, that's a scalar motion, motion that has magnitude but no direction. The time is always getting later and later and later. That's clock time. Clock space is that space is always getting farther and farther and farther apart. And then you also have what Larson calls the discrete unit postulate. Space and time only come in discrete units. There is no minimum, there is no minimum unit of space or time, or there is a minimum unit of space or time. You have to have a full unit before you have anything. If you don't have a full unit, then you don't have space or time. And those units are very small, but they are existent. You have to have a full unit. If you have 1 unit of space in 1 unit of time, space over time, or speed, 1 unit of space in 1 unit of time, you have the speed of light, which in Larson's system he calls unit speed. 1 over 1 equals 1. This is the place, the special place where time and space are equivalent to 1. And so for that marks out that this is the center point of Larson's reciprocal system, or the 0 point, the null point, the origin, the ether, the reference point. Larson calls it the progression of the natural reference system. All points are moving outward at the speed of light. That is the state of rest of a universe of motion, which makes sense. If you have a universe of motion, you have motion before you have everything else. So even the state of rest is in motion. And half of this universe is moving faster than the speed of light, which Larson calls the cosmic sector. Half of the universe is moving slower than the speed of light, which Larson calls the material sector. The material sector is the only sector that the scientists know about. Hence, Einstein's dictum that the speed of light is the maximum speed of the universe. So Einstein is conceding that the material sector is the only sector, and he doesn't know anything about the cosmic sector. Fortunately for him and for the legacy scientists, we can determine things about the cosmic sector without really probing into it, because it is basically a mirror image of the material sector. Exactly what's going on in the cosmic sector is what's going on in the material sector, except in its reciprocal. So you have to reverse the roles of space and time. So in the material sector, you have relationships based on coordinate space, 3 dimensions of space, and clock time. Time is always getting later and later and later. In the cosmic sector, once you cross that speed of light boundary, the rules invert, and then you end up with relationships based on coordinate time, 3 dimensions of time, and clock space. Space is always getting farther and farther and farther apart. So those are the basic relationships. We're going to look into a paper that was written by Dr. Bruce Peret today. This is actually the 3rd installment of this. So if you want to go back to the beginning of this paper, you go back 2 episodes. And this paper is just called Scalar Motion. Dr. Bruce Peret was one of Larson's principal revisers. After Larson died in 1990, the whole thing was kind of up for grabs, and some people came along who were kind of orthodox Larsonians who felt that Larson got everything right. Some people came along that just wanted to revise everything that Larson did. But I think kind of the middle ground was taken by Dr. Bruce Peret and Dr. KBK Nehru, who applied the spirit of Larson's reciprocal system, but also corrected some things that he got wrong or he overlooked, which Larson admitted that he was subject to error as far as that was concerned. He believed that the system itself was correct, but that he could have been mistaken about certain aspects of it, of his derivation, of his deduction of, okay, if we've got the postulates here and the reciprocal system, what kind of a universe does that create? And he took a few missteps as far as that was concerned, according to Larson and according to Nehru and Peret. And so they came out with what's called the RS2, the Reciprocal System 2, the reevaluation of the reciprocal system. And we're looking at, Peret wrote 9 short papers here, RS2-101, RS2-102, and so on. We're looking at RS2-104 today, which is on scalar motion. Now, in the earlier parts of this paper, Peret defined scalar as, something that has a magnitude, but basically no units, no direction. Now he's getting around to defining motion in the context of scalar motion. Okay, so it's giving the dictionary definition of motion: changing place or position. Motion is a simple enough concept to understand, but when you consider it in the context of scalar motion, it becomes an oxymoron. How is it possible for a quantity possessing magnitude only to change place or position when both place and position are totally foreign to the idea of a magnitude only scalar? It cannot, and there lies the problem with the term scalar motion. What is meant by the term motion when associated with the concept of magnitude? The answer is found in how we express the concept of motion as speed, an inverse relation between some quantity of spatial distance, s, and some quantity of time, t, as s over t. Speed is just a ratio of space to time, and therefore is motion, and in a more generic sense, simply a ratio of quantities. It is important to understand that the concept of motion is a subset of ratio, because ratio deal with magnitude, whereas motion deals with quantity, magnitudes of something, namely time or space, time and space. In essence, we have 2 similar concepts, that of scalar ratio, generic, and that of scalar motion, which is specific to space and time. Scalar motion, as used in the context of the reciprocal system of theory, is therefore the projectively invariant cross ratio with specific aspects of space and time. Concepts such as scalar waves, scalar energy, or scalar fields do not exist in the theory. Okay, so let's just reiterate this. Scalar motion, as used in the context of the reciprocal system of theory, is therefore the projectively invariant cross ratio with specific aspects of space and time. So he mentioned earlier that the cross ratio from projective geometry is a ratio of ratios. And I think he's saying that space and time are ratios. And so speed is a cross ratio. Although I could be wrong. I'm a little bit lost. See if he can clear it up for me and maybe you as well. In Larson's books and papers, Larson uses motion as a ratio, not a cross ratio, because he makes an assumption about the absolute nature of unit speed as the natural datum of measurement, and therefore eliminates it from I'm sorry. I'm getting a little distracted here. Okay. Because he makes an assumption about the absolute nature of unit speed as the natural datum of measurement, and therefore eliminates it from the cross ratio for convenience. He makes an assumption about the absolute nature of unit speed as the natural datum of measurement, and therefore eliminates it from the cross ratio for convenience, since 1 over n divided by 1 over 1 equals 1 over n. Now, this section is called the universe of scalar motion. 3 dimensions of scalar motion, the scalar dimensions, are behind all structure in the universe of motion. These can be seen at the astronomical level, particularly the expansion of galaxies that are often described as spots on an inflating balloon. The most common question that students of the reciprocal system ask is, how can you have motion without something moving? The problem stems from the fact that motion is taught as a mechanical quantity, an amount of something, typically velocity, not magnitude, not associated with a unit of measure. Try replacing the word motion with ratio, as it will help to overcome the conceptual programming, because you can have a ratio without anything moving. Okay, I'm going to have to think about this a little bit as I digest it over time. I'm kind of lost. Maybe my concept of ratio is a little bit off. I've read this paper a few times before, and apparently I haven't been able to figure it out yet. I was struggling with it yesterday, but now I'm struggling with it more. But we're going to keep proceeding here. What is actually moving are locations. And for that to work, you need an observer, something to observe, and a datum from which to measure change. Larson's scalar motion has a ratio to observe, a ratio to measure change from the unit speed datum forming the cross ratio, but lacks the observer. So Larson's scalar motion has a ratio to observe, but lacks the observer. Scalar motion cannot be observed directly, but only by how it changes locations in space and time. We call these scalar-induced changes of location force fields, electric field, magnetism, and gravity. I think this is like what I was saying before, that you don't have a direction until you define a reference point with gravitation, which is basically the contraction of a balloon with dots on it. All of the locations on the surface of that balloon are moving toward each other, but they're not moving in any particular direction or field until you define a reference point and you arbitrarily say, this one we are choosing to be stationary, and all the other ones are moving in reference to that stationary one. And then you can impute directions to all of the other ones. And I think that's what he's trying to get at here, is saying that we call these scalar-induced changes of location force fields. So the force field would be that relationship between the reference point and whatever the other the other dot, the other, the other dot that you're choosing, that it appears as if they're attracting each other. They're moving toward each other, but that is not the case. They're moving toward all others. But when you isolate one, you pick one as the reference point, it appears as if there is a force field between the two because they're moving toward each other, but they aren't. They're moving toward all others. This is what he's calling it, a scalar-induced change of location. The scalar motion cannot be observed directly, so you're not, without that reference point, you're not observing anything directly. Only until you define the reference point can you kind of begin to see the motions, and then what you're seeing is skewed. What you're seeing is an abstraction. You are abstracting one point from the whole system, and then making the measurements based on that abstraction. Okay, so he calls it force fields, magnetism, electric field, magnetism, and gravity. These scalar-induced changes are called force fields, even though there is actually no interaction between what is observed. So there is no interaction between these points. We observe it as a force field, but in reality there is no interaction. It's all points moving toward all other points. No need for interaction. Okay, for example, considering walking toward a door, you have an internal motion that is mapped to a location, and that motion is forcing a change of location. You are not being magically pulled to the door by an invisible force. It is solely an underlying motion that is causing your change of location. This is the concept underlying the instantaneous attraction and repulsion of field effects, such as gravity. It appears instantaneous because there is actually no interaction at all. They are independent motions that, when observed, appear to be interacting. The lesson to be learned here is that in the reciprocal system, scalar simply means magnitude only, where the magnitude is a finite number of greater or equal to 1, and scalar motion refers to the ratio of speed, which can be expressed in two forms: s over t, velocity. I think he means speed. Velocity is a speed with a direction. Scalar motion refers to the ratio of speed, which can be expressed in two forms: s over t, velocity, or t over s, energy. I think he means speed there, but I'm long since lost. So I'm not lost, I'm hanging on. I'm a little confused, but maybe not totally lost. Okay, well, in either case, that is the end of the paper. And he's got a few footnotes here, and I'm trying to see if there's anything important in this. No. Okay. All right. That's the end of that paper, and it was tough for me to get through that. But tomorrow we're gonna move on to Peret-RS2-105, which is called quantum pi. Pi, the Greek letter that stands for the relationship between the diameter of a circle and the circumference of a circle. And this paper has also got me a little bit confused, but we will try to trudge through it tomorrow and see how we do. This is, it doesn't seem to me that this is, this particular paper is like utterly fundamental to the reciprocal system too. But for some reason, Peret has it included in this whole bunch of 9 papers. It doesn't strike me that this is fundamental, but I could be totally wrong, and I want to present this in a way, you know, that is faithful to what Peret wrote, because I am not in the position to kind of judge him right or wrong, because I'm confused about some of his you know, some of the things that he says. And so I don't want to put words in his mouth or edit his work out unnecessarily. So we're going to go through RS2-105 tomorrow. And thanks for tuning in today.